Welcome to today's video on solving systems using elimination. We are going to take a problem that is two linear equations and find the intersection point for those two lines using the elimination method. So our problem today is 4x minus 5y equals 13. And the second equation is 6x plus 2y equals 48. Okay, I've chosen a harder problem to do because these are one of the ones that you probably did in Algebra 1, where you had to fix it up a little bit before you could actually solve for the intersection of the two lines. So what we're going to do is we're going to make it so that I can eliminate one of the variables. If I can multiply the 4 and the 6 by a number to make them the same, or I can multiply the 5 and the 2 to make them the same, and then that way I'd eliminate the x's and the y's. But in this case, the 5 is already negative and the 2 is positive, and so when I actually make them the same, they're going to come out to 0. If I multiply the 5 by 2, that'll make it 10. So if I multiply the 2 by 5, that'll make it 10. So a negative 10 and a positive 10 will make 0, so the y will be gone. Okay, but if I multiply the 2 and the 5, I got to multiply the 2 here, and don't forget the 1 over here. This one needs to be a 5 here and a 5 over here. So let's go ahead and add these together. Right here I have an 8 and a 30. If I add those together, I'm going to make that 38x. Okay. Remember that in order to add these together, one of these has to be negative and positive to make this 0 right here. And that's why we have 38x plus 0 right now. The 13 is going to be 26. And I need to go out and check what is 48 times 5. 240. Okay, which 240 plus 26 is going to be 266. Now I can go ahead and solve for x. If I divide by 38 on this side, and the 0 is gone now, 38 on this side, 266 divided by 38 is going to be 7. So x equals 7. Remember, the solution is 7 is a point, so it's 7 comma something. In order to find what the y value is going to be, I need to plug in 7. And I just need to decide which one I'm going to use. I think in this case, I'm going to use the top equation. So I'm going to multiply 4 times 7 minus 5y equals 13. Okay, so I'll have 28 minus 5y equals 13. And I'm going to subtract the 28 on the other side. (13) minus 28 is 15. And therefore y equals 3. So my answer is the point 7 comma 3 is where these two lines are going to intersect. Okay, let's do example number 2. Example number 2 is 3x plus 4y equals 18. And the second line is 6x plus 8y equals 18. Okay, notice that how is it possible that this top equation, a 3x and a 4, is going to equal 18, and these two are going to equal 18? And the point would have to be the same, so the x's and y's would have to be the same in order for the point to work. I have a feeling this is going to be no solution, so we're going to check it out. Let's make them the same. Remember, we're going to multiply by something to make them the same. So we're going to multiply by a -2. Okay, that's going to make this -6 right here, which would make it 0. This is going to make a -8, which would actually make this 0. And this is going to be -36, which would make this -18. And can you say that 0 equals 18? If you ever get to the situation where it's two different numbers and it is not a true statement, the answer to this is no solution. These two lines do not cross. Okay? If we have a graph with two lines that do not cross, they're parallel, then there is no solution to that system of equations. Okay, so we've talked about example 1, we actually found an intersection point. Example 2, we have no solution. So we need to talk about one more. Okay, our two equations are going to be 4x minus 10y equals 18, and -2x plus 5y equals -9. I'm going to go ahead and adjust the equations so that I can add them together. I'm going to multiply by 2 because that'll give me a -4. If this gives me a -4 right here, then this is going to make 0. Okay? If I multiply by 2 here, I'm going to multiply by 2 here. That's going to give me a 10. If that's a 10, that's actually going to be 0 as well. If I multiply by 2 here, which I have to do in order to make sure I've balanced out the equation, then this is going to give me -18, which that's going to be 0 as well. Anytime the problem comes out where the x's and the y's go away, in other words, they make 0, and I could have any numbers here. I could have 0 equals 0 or 5 equals 5. I could anything that is a true statement. This right here is a true statement. 0 does equal 0. And the x's and the y's have disappeared in the process of elimination. If that's the case, then the answer is that these two lines, I'm just going to draw an example. These two lines are actually the exact same line. Okay? I'm just giving you a visual here. This really isn't the line. But if I were to graph these two lines, they would be the exact same line. So every point on the line is crossing the other line. Okay? In that case, the answer is going to be an infinite number of solutions. All right, so that's our third example. One more thing I just want to say. If you're doing elimination, or if you are doing a problem and you end up with the problem is set up like this, I'm just picking some random numbers. When the problem looks like this is what I'm going to do, elimination. Going on to the next video, you're going to see, we're going to do substitution, and you'll see what the equations look like and how they're set up and the reason why we use substitution. But if it's set up like this, I'm going to do elimination. All right, that's it for this video.